Okay. That's kind of cool. Okay, so it looks like the recorder is on, and
That's still just loaded at least.
all right. So let's go ahead and get started. I just made a new distribution, but I have not downloaded my new distribution yet. So this is still the old one, which is okay for what we do here. All right. So first thing first, I'm going to hand the exam back to you guys. I'm not done grading it yet, but since I have already digitized every single one back and forth, using grayscale, so I can hand it back to you so I can finish the grading on my own when you have your exam back to look at. There is no grade on any one of the exams, so unless there's objection in the class, I'll just kind of pass it around because you guys really cannot tell, what is the score of the next person. Is that okay? I mean, are there any objections about passing this around? No objections? Okay, if there are no objections, I'll start it with two piles and have one pile to start here and have the other pile to start here. So if you don't see your name in one pile, don't worry. Just wait for the other pile to come around to you. All right. Okay, that's good. And up to this point, after grading the first 4 questions, quite a few people got 100% up to this point, so I'm pretty impressed. Quite a few people got 90+% also, so that was pretty good too. And that's including one of the heavy hitters. I think question number 4 has 10 points, and to my surprise, which is good, a lot of people who missed the first 3 questions in one way or another got the 4th one perfectly. Okay, which is the big deal because the 4th one is worth 10 points. The first one is only 2 points, the second one is 2 points, 4 points, and then the third one is also only 2 points. Yep.
Are the answers online?
The answers are not online. I talked about it on the other day, the Thursday, the lab time. So you can also check out the lab video of that day, and I had the basically the key discussed already on that day. All right. So if you go to YouTube and go check out my channel, this is not my channel. Sign back in. Oh, this is bad. Channels are getting all mixed up. So if you go to my channel and look up the recording from last Wednesday, it has all the keys, the answers to the exam. I also briefly explained every single one of the questions last Wednesday, so for those of you who stayed here, you know the answers already. If you were not here, which I understand, you can watch the video and it should all be there already. Okay, so with that out of the way, I'm going to move on and talk about the solution of the homework assignment that was due 5 minutes ago. What? There's a homework today? All right, so this one is not really intended to be very difficult, but it is a chance for you to kind of practice, how much you know about control structures. And you have a new homework assignment, which is, I would say, just a little bit more difficult than the previous one. So I'll talk about the current, the one that was due 6 minutes ago first, okay? And then we'll talk about the new one, okay? The new homework assignment is called Find Factor, which we have done already once with recursive subroutines. This one is not recursive, and you kind of have to use loops to do it. All right, so first thing first, we'll go back to the homework assignment that was due about 6 minutes ago. This is find max 3. A particular function called find max 3 has 3 parameters, x, y, and z. And your job is to fill in the stuff on line 5 and line 6 so that max actually has the value of the maximum of the 3 variables. Okay. And you're not supposed to reuse Fimax 2 or use ternary operators in this case, because I want you guys to use statements instead of expressions to get the same thing done. So are there any questions before we kind of move in and talk about this one? Okay, no questions. All right. So I'll just give you one solution right now. During the lab time today, I'll give you some alternatives to the solution of this particular homework assignment. As far as I'm concerned, there are at least two main methods to get this done, if not more. There are many other ways to get it done as well. So I'll just go ahead and use this terminal, go to my temp folder, and create, okay, this is the procedure to do it. You have to create a folder first, and it's called find max3. Go to the subfolder, create the document itself. You know, I can do this because I'm in Linux. If you're in Windows, you can probably not, you cannot do this easily. So I go into main.cpp, and I have all these leading spaces here, and they're not good. Okay, so in VI, I can just get rid of all of these at the same time, like that. Oh, that it got rid of too much. 1, 2, 3, 4, 5. Huh?
What was the code?
Okay, so I have, okay, wait, hold on a second here. 1, 2, 3, 4. So I have 4 spaces before each line, and I need to get rid of 4 spaces on each line. So what you do is you type colon in VI, and you say 1 to end of file. So the $ is basically the line number of the last line of your entire file. And as for substitution, and you just give it 4 spaces here, 1, 2, 3, 4, which is what it's searching for, and here's what it's replacing it with. Now, to be sure that you're only destroying the first 4 spaces and not some 4 spaces in between, you can also put a caret. The caret symbol in VI means the beginning of a line. So now I'm restricting the search pattern to say the first 4 spaces of each line. And then the second part, which is the // is basically specifying the replacement string. Since I'm not putting anything between the slashes, it means the replacement string is empty. I'm replacing 4 spaces with nothing. And then the G is not really necessary here. It means multiple replacement on each line. And now I have fixed the entire program with one single command. There are other ways to do this too, but this is one of the many ways to do it in VI. And that's why I kind of like VI, because it has, it's pretty powerful as an editor. Okay, so we'll go ahead and just, I'll give you one solution to do this. So one solution to do this is really just to look at one comparison at a time. And you guys still remember, I'm hoping, that this is the way I do things. Okay, whenever I use a conditional statement, I would, give it the then branch and also the else branch automatically, and then go back and fill in, what does it mean to be in the then branch and what does it mean to be in the else branch. Okay, all right. So getting back to one of the branches, the first thing I usually do, even though in this case it's really clear, is to use comment to remind myself, what does it mean to be here? And I can do the same thing with the other one. So with the else branch, it is more important that you specify the condition. I don't need this, okay? If you type the entire program on one single line, I'm not going to take any points off. Now, in many other programming classes, people will get points taken out if they do not conform to the formatting, the commenting, and style of a particular professor. And I'm not going to do that, okay? There's no real reason for me to do that, to enforce this kind of standard, because your employer will. Assuming that you're going into the programming field, your employer will eventually tell you and say, okay, if you are going to do coding in this company, you have to code it in a particular way. And that way may not be the way that I want either. So I don't want to put any particular standard on you, but I do want to explain to you why it is important. The else branch is particularly important because when you get to the else branch, visually, it is too far away from the condition on line 6 already. So if you don't want to have to match the else with the if and use indentation to kind of trace your way back to the original condition, this is really helpful, because what it says is by the time we get to what we know as line 13 at this point is, okay, we can confirm that x is greater than or equal to y. And that's what commenting is really for. It's for your convenience. It's not for me, okay? It's not for the compiler. It is for the developer, okay? Whoever has to read and debug the code. Okay, so getting back to here, I want to find the maximum. And I already confirmed that x is less than y. So x is I don't have to consider x at this point because it is already less than y. So it's really just between y and z at this point. So I will say, let's go ahead and compare those two. Any comparison other than equal to or not equal to will work here. And the same thing, I put in the then and the else branch here. Now, in this case, if I ever end up here, I actually am confirming two things at the same time. Because in order to get here, x has to be less than y, and y has to be less than z in order to end up on line 11. So at this point, I have my answer. The maximum has to be z at this point. Okay. Are there any questions? Okay. Now the else, yep, go ahead.
Shouldn't the second if be inside the first else? Because it's a part of
The else is going to have its own nested conditional statement as well. But I'm not there yet, so I'm not really too concerned about it. Okay. Now the else branch here, since I want to be consistent, I also want to say that at this point I know that y is greater than or equal to z. But at the same time, to get here, x also has to be less than y. Now if I know that y is greater than or equal to z and x is less than y, do I know which one is the maximum? Which one should it be? Y, that's right. All right, so I am now done with the then branch of the outer conditional statement, starting on line 6. And now I can move on to the else branch of the outer conditional statement. And at this point, the only thing I have confirmed is x is greater than or equal to y, which means, well, it's all between x and z at this point. So I can now reuse the same kind of logic, but not exactly the same. I can just compare x to z in any way other than just comparing for equality or inequality, not equal to. At this point, I'm going to comment and say x is less than z, okay? But at the same time, we also know that x is greater than or equal to y, because we wouldn't be in the else branch of the outer conditional statement if that is not the case. So I can actually confirm two comparisons by the time I get to line 25. If I know that x is less than z and x is greater than or equal to y, that confirms which one is the maximum. Come on, you guys know the answer. Z is the maximum. All right, very good. Now for this particular else branch, it is in the else of the inner conditional statement, which is also in the else of the outer conditional statement. So that means at this point, I know x is greater than or equal to z because of the inner conditional statement. We also know that x is greater than or equal to y because of the outer conditional statement. So at this point, we know the max is x, okay? And that's my entire program, okay? And you can see that each time I only handle one part of the program, okay? I don't try to type the program or type the subroutine from start to finish in one single shot, okay? I personally cannot keep track of logic like that, okay? I have to do it in a kind of more of a hierarchical or nested fashion. Some people can keep track of a lot of logic in their mind, and I just cannot, okay? But I think this is a fairly easy way to handle a program because at any particular time, you only have to handle a small piece of the program. All right, so now that the program is done, I'm going to save the file, and I'll go ahead and test it. G++ dash, I recommend using warn all, okay, even though we know it's going to complain about X in main, dash G for debugging, dash C for just compiling the program into object file. And sure enough, it's just complaining about X in main, which is okay. We know about that one already. And then we go ahead and link the program to an executable. Yep, go ahead.
So when you write the program, so when we use the debugger and we get any warning, so it's fine for us or not?
This particular warning is okay, because we are just, forcing the program to compile with, that makes use of the subroutine. So that's okay for this particular one. And he also says right here, if you want to disable this one, there's probably a way to disable it. This is how you enable this particular warning, but you can also disable the warning by using some other options. So if a particular warning message is not meaningful to you, you can actually turn it off. All right, but we have the executable at this point. We say gdb main, and as we have already talked about in a previous lab, you put a breakpoint in main first, run the program, and I'm not even interested in findmax3123 because remember last time we talked about how to use a script to debug your program. So I'm hoping that some of you have set up a script to do it. Did you guys find it useful for those of you who did set up a script? Okay, because you only have to set it up once, and then every time you make any change to the program, you can retest the program for all the test cases that you have thought up at that point. Okay, so that's really particularly helpful. So I'll just go ahead and say print, I'm doing the manual checking part here, 233, that 3, okay, that's 32. Let's change this, and I mean, you can probably get the idea of, just run it through all the test cases and make sure your findmax3 does work in all cases. Yes?
Are there consequences to not putting or equal to in your if statements?
You can do the or equal to, but you have to make adjustments. With this particular type of logic, it is okay, whether you use greater than or equal to or less than or equal to. But if you use the other way, which I will talk about during the lab time, then it becomes really critical. Do you use less than or equal to? Because one way works perfectly, the other one works most of the time. So we'll talk about that during the lab time. Okay, so I will show you the other way to do this homework assignment, but that way is more tricky because you can end up with a program that works in most cases, but not in all cases. This one is pretty easy to figure out. Okay. Are there any other questions? No other questions? All right, so if there are no other questions, we're going to move on to the next program. And remember how I will grade this program. I will give it test cases. And that basically determines your score. If all the test cases work just fine, you find the right answer for all the test cases, you get 100%. If you miss 1 out of 4, for instance, okay, I'm not saying that there will be exactly 4 test cases here, you get 75% of the score. That's basically how it will be graded. Okay, but I will also manually kind of go through the source code as well, just to take a look at the source code and see how many people put the entire program on a single line, just for the heck of it. And you can also do that, I'll just kind of show you what I mean by putting the entire program on one single line. In VI, if you use uppercase J, it means to join a line with the next one. So you can basically just use that repeatedly and merge the entire program onto one single line. Now the comment doesn't work in this case, so I have to find out all the comments. I probably should have done it before I do this, huh? Okay, let's undo. Because the comment doesn't work this way. The way I wrote the comment, like this one here, the comment ends at the end of the line. So end of line is important as far as commenting is concerned. So I have to take out the commenting first, which is like this, okay? So you go from line 1 to the last line. This time you look for backslash, backslash, and then all the way to the end of a line, and replace it with nothing. Okay, so I'll briefly explain what this is, because this is a programming class, and I think this is not beyond your ability to understand it. It's just you're not used to the notation, okay? But once you get used to the notation, you know exactly how to do it. The backslash in front of the slash is an escape character, because the slash symbol itself is used to delimit the strings, so I cannot easily specify just a slash in the search pattern itself. So in order to put a slash in the search pattern, I use backslash as an escape character. So backslash and a forward slash means just a single slash as a part of the pattern that I'm looking for, okay? So I look for 2 slashes. The dot is basically saying match anything, okay? Anything can match a dot. And the asterisk means for as many times as possible, okay? So keep going. until we see the end of line. The dollar symbol means end of line. In other words, this means look for any pattern that starts with slash slash and then match everything up to the end of that particular line. That's the search pattern. I'm replacing with nothing because the second slash here, this slash, marks the end of the search pattern, and between the second slash and the third slash is the replacement string. In this case, there's nothing to specify for the replacement string, which means it's empty. And then the G means just to apply it to everything on the same line, which is not necessary in this case. So when I press the Enter key, then all the comments are gone. Woohoo! And now I can redo the other part. Now, when I redo the other part, I can kind of do it easily too. The other one part of this program that cannot be combined with other lines is the pound line. Okay, so I'm going to have to exclude the pound line. So this will be a 2-line program instead of a 1-line program. So with this one, I can now specify, you can specify a count before you perform a particular operation. So there are 42 lines in total here, which means I have to perform like at least 41 joins. So I type 41 on the keyboard, which you cannot see. Okay, that's a count. That's the number of times I want to perform an operation, and then I specify uppercase J, and it performs join exactly 41 times, which now combines the entire program onto one single line. Okay, which is kind of difficult for us to read, right? But let's check whether the compiler thinks that as well. And the compiler says, hey, it's all good. I'll give you just one single warning, which is the same warning as last time. It doesn't bother the compiler a bit. Yes?
If I packaged my script file with my assignment, is that going to conflict with yours?
No, that's fine. Yeah, I can overwrite a script, and you are probably not going to use the same name that I'm going to use anyway.
It's find max3 GDB.
Yeah, I think mine is going to be test.gdb, so it'll be fine. Yeah. And even if they're the same name, my script will overwrite the file with my version of the test script. So it's going to be okay.
Okay.
Yep. Right. So that is a good illustration of what the compiler can handle and what we can not handle, actually, in this case. I mean, some of you can match the curly braces and actually figure out how the program is structured, but it is a lot harder to read this program than the other one. Okay, you can do it, but it's not as easy. All right, so now with this out of the way, we'll go ahead and talk about the new homework assignment. It is right here. All right. Okay, I can see someone's getting distracted. It is fun. I mean, I can see it's really kind of well put together. Okay, so a new homework assignment is find factor. Okay, find factor has just about the same format as your previous homework assignment, except this time I'm not looking to find the maximum of a few numbers. I just want to find a prime factor of a particular number. In this case, the parameter is x here. Okay. And the instruction is pretty much the same one as the one before, except instead of find max3, it is find factor. That's pretty much the only structural difference between this one and the previous one. And you have to do the same thing here. Insert your code to find a prime factor of a parameter x and store that in factor as a variable, as a local variable name. And we'll go over how to test a program like this on the 23rd of the last month, because we have done that already. Okay, so you can go back and figure out how to do that.
What does this do?
This one is due in a week, so it's due. Okay, I'll reset the time. As you can probably see, I did a copy and paste, but without modifying the due date. So you have a week to work on this one. I'll definitely fix that one, so don't worry about it. Okay, I'll fix it now just in case someone wants to turn it in right now. I think you can turn it in right now. It will just count it as late. I'll do it later. Okay, so are there any questions about what the program is supposed to do? Are there any? Find a prime factor of x. Yep, go ahead.
gotta just go even to it.
Say again?
I was just saying what you said.
Okay. Yeah, so with 26, you can either return a 2 or a 13, okay? Because 2 is a prime factor, 13 is a prime factor as well. If you call find factor on 25, it has to return a 5, because 25 is 5 times 5. What about 23? What is the smallest prime factor of 23? It's 23 itself, okay? Because for any prime number, it is its own prime factor. But what about 1? Can I use just 1 for everything? Why not? Because 1 is not even a prime number. By definition, 1 is not a prime number. Some of you will say, but I don't believe it, show me. So we go to the most authoritative source here, which in many of your other classes will say, do not use Wikipedia. Well, a prime number or prime is a natural number greater than 1 that has no positive divisors other than 1 and itself. So right there, it excludes 1 itself, okay? Now, when you test your program, you don't have to test with any number that is less than 2. So start with 2 as the parameter. Okay, so I'm not going to give you any tricky test cases like what is the smallest prime factor of negative 23, okay? So it's going to be 2 or up, okay? That's the constraint that you can rely on. Okay, any other questions? All right, so how would you go about doing this? Now, this has nothing to do with the control structures that we have talked about up to this point. It is not even a part of the curriculum, because in this class, I'm supposed to teach you the syntax of C and C++, but not really quite how to design or how to write a program. I just give you the tools, and I just say, build a dog house, and then you go build a dog house. Okay, but how would you go about writing a program? I'm just kind of overlapping a little bit with cisp360. How do you write a program like this? Okay, you need a loop, but how do you know that you need a loop? How do you know? Okay, first of all, if you don't know how to do it, can you tell the computer how to do it? No. Okay, so how do you do this? So you have to give yourself some examples, right? So we'll go ahead. I'll just spend a little bit of time to talk about this, because I think some people can probably benefit from this experience. Okay, so I'm gonna start a new document here, and I'll give you a particular number that I don't even know whether it's a prime number or not. Okay. And does it look like? Yep, that'll work. Okay. So let's say the number, the value that I'm passing to x is 6,731, okay? Which I don't know right now whether it's a prime number or not. Does anyone know whether this is a prime number without looking it up first?
Which number?
6,731, 6,731. All the rules of thumb do not work, right? Okay, so that means that it's a good number to start with. Because if I told you, okay, let's say x is 24, then all of you will say, oh, we know it is divisible by 2 and 3, okay? Even if I give you like 91, okay, many of you still remember this is 7 times 13, okay? Because these are the things that we're already familiar with, and it's not going to force you to think about the problem in a structural way, and that's not going to help when you're writing a program. Okay, and that's why I do not want to use simple examples like that. So with 6731, how do I know whether this is a prime number, or what is the smallest prime factor of this number?
Start dividing it by number.
You can start dividing, exactly. Okay, now what is the first prime number? 2. Okay, so we'll start with 2 here. And you can also rely on mod, okay? I'm hoping you guys still remember how to use the mod operator in C++. If not, look up the notes, okay? Because we talked about this already. The dividend is just this number, and because this is a spreadsheet, I'm gonna use a spreadsheet trick here to force the use of row 1 in this case. And the divisor is just the one next to it. And since it has a divide and since it has a remainder of 1 after it is divided by 2, that's confirmation that 6731 is not divisible by 2. 2 is not a factor of this number. And then the entire class will say, well, that's pretty dumb. We already know that. This number does not end with 2, 4, 6, 8, 0, so by rule of thumb, we already know this. But the whole point is I don't want to use any rules of thumb when I'm programming, okay? Because none of that is going to be able to program into your program, okay? All right, so I'll even put in something like a conditional statement here, and yes, you can have conditional statements while expressions is more like a ternary operator in a spreadsheet, which is actually very useful. Because now I can say, if this is non-zero, I want to say not a factor, and if it is divisible, if it is 0, then I'll say is a factor, okay? And now I can have a verbal confirmation whether this is a prime factor or not, okay? So which number should I try next?
3.
But that's pretty dumb because I can see that 6 plus 7 plus 3 plus 1 itself is not a multiple of 3. Once again, I don't want to use any rules of thumb, okay? I just want this to be as easy to code as possible. Rules of thumb are very difficult to code because the rules of thumb depends on the base that you're using, and what is the base that we are using right now? It's base 10, right? But internally, numbers are represented in base 2. So all of the rules of thumbs cannot be applied directly when you're dealing with the internal representation of a number. Okay, so I'm going to try 3 here. Okay, instead of writing 3, I'm using another feature of a spreadsheet, which is to use another cell to calculate the value of this particular cell. Not a big deal, right? It's just basically saying this number is the value of the previous one plus 1. And I can now extend this one down and say, oh, okay, if you divide 6731 by 3, the remainder is 2, and because it is non-zero, it is also not a factor. What is going to happen next is even dumber than the previous 2, because I'm going to try 4. But tag, we tried 2 already. If 2 is not a factor, 4 cannot possibly be a factor, right? But remember, I'm trying to make this algorithm as easy to write as possible. Now, if I want to make this algorithm efficient and skip all the non-prime numbers, guess what? You have to find all the prime numbers first, which makes it kind of difficult, okay? So the main concern is, if I try 4, is there a chance that this program or this logic will accidentally consider 4 as a factor of 6731 and give me the wrong answer? Is it possible? If I use the same logic, okay, I divide 6731 by 4, is it possible that the remainder is a 0? No, mathematically speaking, that is impossible. So I'm really just wasting time, but I'm not being incorrect here. Does everybody understand what I just said? It's not the best thing to do, okay, because it's a waste of time, but it cannot possibly give me the wrong answer, which means it's okay to do it, it's just not worth the time, okay, from a certain perspective. So I'm going to use this approach and just be a little bit lazy and find out, okay, up to 15, it's not, no. And you can see how a spreadsheet can be really helpful here, because I have just found that 53 is a prime factor of that particular number, which obviously I did not know ahead of time. But that's the whole thing about the spreadsheet, is you can just do it, quickly. Okay, so I'm going to use this spreadsheet to help you, structure your program. Okay, why do I know this is going to be a loop? At least we know this will involve a loop here. It's a lot of repetition, right? Okay, so whenever you see a lot of repetition, you know that it's going to be a loop. On top of that, how do I know when do I get out of a loop? You can see that in order to keep trying, it's not a factor, not a factor, not a factor, until I find something that is actually a factor. Okay, so I cannot get out until the number being tested is actually a factor of x in this case. Okay, and since we know it's a loop, you also have to find out how we go from one iteration to the next, and then to the next one, to the next one, to the next one. Okay, I'm not going to say anything in this case because it is so obvious. Okay, that's about it. So I'm going to change this number to another number here, which is going to be a prime number. So let me try. I don't know whether this is a prime number or not. Let me try 127. So 127, if I remember correctly, is a prime number. So this one is going to be a fun one because it keeps going and going and going and going a little bit more and a little bit more. There we go. Okay, so by the time we get to 127, it says 127 is wholly divisible by 127, which makes perfect sense. But that's the first number that is found as a factor of 127. That's because 127 itself is a prime number. Okay, so you kind of have to think about, okay, in the case that x itself is a prime number, is the logic any different from when x is not a prime number? Okay, that's a question that I'm posing to you. I'm not going to answer that question, but you kind of have to think about the logic of all this stuff here and say, well, is it really different? Okay, so you got to think about it a little bit. Yep.
Is this one assignment should return all the factor of the number?
No, just one of the prime factors.
That's one.
Just one of the prime factors. So some of you who like to go to like casinos can use a random number generator. So you can just, for each iteration, you just say, okay, let's try this number, let's try number. But how do you know the random number itself is a prime number? Okay, so you still have to, there are still issues with that approach. Okay, this is the best I can do to illustrate the logic of this program. Okay, so using this illustration, try to figure out the code to do it. There was another hand, I think, earlier. Nope. All right. So I'm just going to leave it like this, okay? And I'll leave it up to you guys to decide how to, tackle this program. One restriction that is not written in the homework description itself is you cannot reuse one of the sample programs that I have written before. Okay, I think about 75% of the class is going like, what? Which program? And then the other 25 is like, shucks, I was just about to do it. Okay, I'm going to pass the roll sheet at this point. I think it's fair, about 38 minutes into the lecture. Okay. And we'll go ahead and get rid of this. All right, so find factor is your next homework assignment. And we'll go ahead and continue our discussion of input and outputting using files. Okay, and remember last time we kind of talked about files and we debunked a lot of myths about files. Okay, so consider the previous class or the previous lecture on lecture material to be a mythbuster session on files. Okay, because we just busted a lot of myths about files. Now, what myths did we bust? One, a file doesn't need to have a name. Two, a file does not need to be stored on anything, right? Okay, and three, a file does not have to be, in a folder of any kind. Okay, doesn't need a name, doesn't need a containing folder, does not even need to be stored. Now, it can be all those things too, but that's kind of like extra stuff. Okay, all right. So the bottom line of what a file really is basically something that a program can write to byte by byte, and it's something that the program can read from byte by byte. Okay, so the first thing we want to do, we want to understand is how do we represent content in a file. Okay, for instance, if I do an ls right now, I can see there are 3 files in this folder. Okay, so these are not the kind of minimalist files that we talked about before, but we want to know what is exactly in these files, particularly what is in main.cpp, because it looks like we can view the content of a file using Vim here, which is a text editor. So what exactly is in that file? Now, one way to do this is to use a program called hexdump in Linux, and I believe it is also installed on the virtual machines that you guys have. Now this program is kind of interesting because you can give it any file and it will basically come back and say, okay, this is the actual content of the file byte by byte. Okay, so I'll show you how to read this particular output. On this side, okay, if you look at this side here, that is showing you, okay, first of all, these are the columns, okay? The first column is showing you the offset into the first byte of each row, which basically is saying the offset of 0 is going to apply to this particular byte here. So 23 is the hexadecimal value or hexadecimal representation of the bit pattern of the first byte of this particular file. Are we doing okay so far? At byte location 1, okay, since this is location 0, this is location 1. Location 1 has a byte that has a bit pattern of 69 in hexadecimal. Now 69 in hexadecimal is basically 0110 1001 in binary. Okay. Now the conversion between base 16 and base 2 is pretty easy. It's just a lookup kind of thing. Okay. And then the next one is 60 and so on. Now the third column, this one here, is showing you that the byte 23 in hexadecimal is also known as the pound symbol. The byte that has a hexadecimal representation of 69 is also known as lowercase I, and so on. In other words, this is how we represent letters, digits, and punctuations in a file. Okay? There's one particular bit pattern for each letter, punctuation, or digit that we want to represent in a regular file. Are there any questions about this part here? Because with a computer, everything is a byte. Okay? So when you type a program, the text of that program is also represented in individual bytes. So we need to find a way to map what you type as text into, basically individual bytes. Are there any questions about this particular screen? If not, I can move forward. If there are any other questions, I can answer those questions here. Well, I have a question here. What about end of line? Okay, how can we tell something is end of line in a file like this? Okay, because I don't see any end of line on this side. I don't see end of line here. Well, I can tell you right away. Do you remember, after the pound include stdint.h and the close angle bracket, we have an end of line? So that means the end of line is actually this character here. It's using a dot only because it's not quote unquote a printable character. So all non-printable characters will use a dot to represent it on the right hand side. But you can see this is the fourth character from the left. And when you count the fourth byte on the left, it is a 0A. So 0A, which is in binary 0000 1010, is representing end of line. Okay? So end of line itself, which is a non-printable character, is also represented by what we call an ASCII code. Okay, well that's kind of interesting. Okay, everything that I type in a program is represented by a byte. Okay, well, yeah, every character is represented by a byte, and we kind of have a mapping here. But how do I look it up? If I want to know the ASCII code of a space, for instance, okay, which is this byte here, that's a space. How do I find it? Okay, in this particular file, it's easy because we can just use the offset and find a 20 in hexadecimal is representing a space in the text file. But in general, how do I find this mapping? Well, fortunately, in all Linux distributions, or as far as I know, in all Linux distributions, there's a man page, which stands for manual on ASCII. And this is it. This is a whole table for how you can look up the representation of each individual character. ASCII, ASCII, stands for American Standard Code for Information Interchange, which is a pretty obscure way to describe a text to binary code mapping. That's basically what it is. Now, why do we need a standard like this? How come, I cannot just use text standard of, letter punctuation and digit translation, and you can use your own.
Communicate with each other?
Exactly. Then how do you specify what program, how to print out a program with a printer? So there has to be a standard. Otherwise, your devices cannot communicate with each other. And this is the standard that we use these days. This is not the only standard, by the way. For those of you who will have the privilege to work with mainframe computers from the 60s, you will also know ASCII. Okay, ASCII is, gosh, I cannot remember how to spell ASCII. ASCII. There we go. This is a IBM standard. It stands for Extended Binary Coded Decimal Interchange Code, I think. Okay, you can look it up on Wikipedia and find out the exact name. But it's a different way to map letters, digits, punctuations, and non-printable characters to binary code. But it is not commonly used today anymore, so we don't really care about ASCII for the most part. Okay. All right. So if you look up this table, you can find, let's just say, the caret symbol here. Okay. This is the caret symbol. This is what it looks like. This is its representation in hexadecimal, which means in binary, this is 01011110. Okay, I can do the translation because 5 maps to 4 bits, Eve maps to 4 bits, and I can just combine those two, which is also known as 94 in decimal. Remember, 94 versus 5e versus 01011110. They're all different names for the same quantity. Because by changing the base that we are using, we're just changing the name. They're still representing the same quantity. It's just that we call it differently. Okay. Are there any questions about the ASCII table? No questions about the ASCII table? Okay. All right. And I think last time I also illustrated, how a program, or every single program that you write in Linux actually has a few files available to it already. Okay, so we'll go ahead and repeat that experiment. And in this case, we'll go ahead and let's say make a new folder, and I'll just call it files. And most of you still remember the printf statement, okay, the printf function. So we'll go ahead and say new.cpp. All right. So, but before we compile the program, this time we do want to take a closer look at this program and say, I don't see any use of files here. Okay, because it's not explicit. Printf is not print file, so that F actually does not correspond to file. Printf stands for print formatted. Okay, but it is printing to a particular file. That file is called the standard output file. Okay, the standard output file is one of the 4 files that are available to any program, written in Linux. All right. So we'll go ahead and take a look at this part here. This is just a convenience. In other words, this saves you the trouble of having to look up the ASCII code of uppercase H, lowercase e, lowercase l, blah, 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 blah. Okay? In other words, when you say double quote in Linux, in C++, it's a way for you to specify a string or some kind of text without having to translate every single character into its octal or hexadecimal representation. Are we doing okay so far with that part? It's a convenience, okay? It's just a convenience. A \n at the end here is the line feed character. Do you still remember the ASCII code of a line feed character? The 0A in hexadecimal, that's the line feed character. Which basically means I can do something like this, and the program would behave exactly the same way. You can escape and specify an X here, which is basically saying I want to express the ASCII code in hexadecimal. In this case, it's 0A. I think this program should behave exactly the same way as it was, specified a little bit before. So I'm going to save this program and do a G++ on this one. Warn all -c hello.cpp, and we want to. Well, we don't really need a dash G in this case. So G++ -o hello.o, and just run the program. Okay, so this is proof that the \x 0A is a way to enter the line feed character, but in hexadecimal digits. I could have specified the entire string using \x blah blah \x blah blah. It would take longer, okay, but that will give me familiarized with the ASCII code table, which is something that I do not want to do. So that's why I just type in the program the way it is. Okay, all right. This program is using a file. It's using what we call the standard output file. In other words, a standard output file is an entity where this program can specify and say, okay, byte by byte, okay, this is what I want to output to this file. The best way to imagine an output file is a conveyor belt. Okay? So if you want to envision, how we want to see a file in this class, this is a program, okay? It's below, okay? So you just kind of imagine that the standard output file is one of the conveyor belts either getting into or out of this particular program. In this case, the standard output file, which is also known as stdout, standard out, is a conveyor belt that is going out of this program. So when you use printf, what you're really doing is you're putting stuff on the conveyor belt, starting with the first thing that you want to output. So in this case, it is a byte that has the ASCII code of H, a byte that has the ASCII code of E, L, and O here. So I'm still in the process of outputting the content of the program. I'm spelling hello backwards because H is the first letter coming out of this conveyor belt. Okay. Are there any questions about this program here? I mean, this particular part about a file is nothing more than a way to output something out of a program, byte by byte in a particular sequence. Questions about this? Where is this conveyor belt going? I don't know. Hello as a program does not know and does not care either. Okay, so that's the bottom line, is a conveyor belt coming out of this program, but where it goes to, the program itself does not know, and neither should it care. All right, so in a normal case, when we just ran this program, okay, I'm going to draw something on the other side. This conveyor belt eventually connects to what we call a TTY terminal, a tally-type terminal type, which is a name for basically the console of what you see on screen at this point. Okay. So on this side, we have what we call a TTY terminal, and what this thing is doing is grabbing the bytes one by one out of the conveyor belt and actually display that on the screen. Are we doing okay so far with this one? So when it serves as the input into something, it is, well, I'm not going to talk about the name. We'll deal with that next, okay? But this is a one-way conveyor belt. Almost every conveyor belt only goes in one direction. It's not bi-directional. Are we doing okay so far with this picture? All right. Can I connect this conveyor belt to something other than TTY? Can I connect it to, let's say, an actual file and store the content coming out of this program? And the answer is yes, and this is a very useful technique. So what I'm going to do next is to illustrate, how to redirect the output of a program and store that into an actual file that has a name that is actually stored on a hard drive. So in this case, I will say hello.log, okay, which is a fairly typical name to basically log the output of a program. So in this case, what I'm doing is I still have a conveyor belt, okay? And hello as a program still really does not care where the conveyor belt is going to. But in this case, the conveyor belt, you can kind of imagine that it's going into a box, okay? You know, and this box is basically storing whatever is dropping off of the conveyor belt. And this box is actually non-volatile. Has a name called hello.log, and it will be stored in the file system. Are there any questions about this analogy? But as far as hello is concerned, it doesn't know how the conveyor belt ends. Okay, so let me just run the program first and see what's going to happen here. Press the enter key. Nothing is displayed on the console anymore because guess what? It's no longer connected to the console. Okay, I have substituted the console, which is TTY, with a box to store whatever is falling off of the conveyor belt. And that's why it's not displayed on the screen anymore. However, if you look at the content of the file that is supposed to capture the output of the program, it is just hello world. And it makes perfect sense because we packed everything into the box, but it's still the same content as what came out of hello itself as a program. Are there any questions at this point? No questions? Right? Okay, so that's kind of cool. And there are special files as well, in Linux. And one file is in the device DEV folder, and the file name is just null, N-U-L-L. Okay. This is also known as the black hole. Okay, it's supposed to be a container, except it's not a box. It is a black hole. It has no end. So whatever you output into the black hole is just simply lost. Okay. Someone's going to ask, why would we have something stupid like that in the file in the file system? Why would we need a black hole file so that whatever is dumped into it is just lost? It just disappears. What do you think? Well, go ahead. Does anyone want to give it a try?
Free memory.
To free memory. Well, sometimes the output of a program is not useful. Okay. Now, the output of a program is useful when you are interpreting the output, right? But what if you're running a program from a script? Now, if you run a program from a script, there are kind of chatty programs who likes to spew out a lot of stuff. Okay. For the most part, it's intended for a person to read it in real time. But what if it is being run from a script? It's not. There's no person actually reading the output of that program. Well, you don't want to log it because it would just be using up space, right? And so a lot of programs would do something like this and basically just say, okay, toss the output of this program into the black hole because nobody is going to read it. All right. So, are there any questions about files up to this point? Okay, if there are no questions, we'll go ahead and actually go into these particular chapters. So we are looking into the classic Hello World program, and that should not be a big surprise to you because we have seen it already. And the program looks like this, which means the syntax highlighting is gone. I'm gonna put it back in first. So don't worry about this part. I'm just doing my HTML magic here. I think that's all I need to do. There we go. So I'm hoping you guys find this program somewhat familiar. Except for people who fell asleep in the past 10 minutes or so, right? Okay, because this is exactly what I wrote. Okay. And the rest of the explanation is just on a line by line basis. Okay, what is each line doing? So what you really need to do is to read this entire text here and make sure that you understand the notes itself. Okay, which is a repetition of what I just said, but the order may be a little bit different. Okay. I did not explain piping, well, not today, but I did explain that 1 week ago. So I'll go ahead and do it again. Piping means you can take the output of one program and feed it into the input of another program. So what I'll do is I'm going to use a program called WC, which stands for word count. Okay, this is also what I did last time too. When you run WC all by itself, which is a program that is already installed in Linux, it will just be doing nothing because it's waiting for you to type something. Okay, WC is by default, is taking the console as the input. In other words, it's quite the reverse of hello. If you look at WC, so here's a program called WC, okay, and it is expecting something to go into the program. Okay, it has an input file. This is a default input file, which also has a name of standard input file, or STDIN for standard in. Okay? So this is STDIN, standard input file. I haven't typed anything yet, and that's why it's giving me this empty look and go like, okay, give me something to process. That's basically what it is doing right now. It's waiting for me. So I'll go ahead and type something. I'll say, this is a nice day. Okay, press the enter key. Hey, it's supposed to tell me that I have just typed 5 words. Well, except it doesn't know this is the end of the input. Okay, it's waiting for me to say, this is the end of the input, now go do all the processing. Okay, and that's why it's not giving me an answer just yet. So I can type as much as I want. Okay, tonight to be stuck in a boring programming class. Okay, press the enter key. It's still waiting. So how do I tell the program, I'm done? Okay, go ahead and process. Control D on the keyboard. Okay, Control D, not Control C. Control C may seem to do the same thing, but it's not the same thing. Control C will stop a program from executing with no way of continuation. Control D, on the other hand, is simply saying, okay, I'm done specifying or I'm done putting stuff on the conveyor belt. Now make it turn and process it. Okay? So if I type Control D on an empty line, it only works when the line itself is empty. When I press Control D, it will go ahead and process, and it tells me that this particular file, okay, the stuff on the conveyor belt going into WC, has 2 lines, 15 words, and 72 characters. That's the output of WC. Any questions about what WC is doing? Okay, so now that we know WC has a default input, it also has a default output, because guess what? Guess what is printing, 2, 15, and 72? It's being printed out to standard output file. In other words, WC is making use of at least 2 files that are available to it. One is standard input, the other one is standard output. So on the standard output, it gives me the feedback of 2 lines, 15 words, and 72 characters. Are we doing okay so far with what WC is doing? So what I want to do now with this picture is easy. I want to hook up this conveyor belt. In other words, I'm now taking the output of the hello program and putting into WC for processing. And the way to do this is called piping, and you do it by using the pipe character. So you run the first program just like you normally would, but you don't use the greater than symbol because we are not redirecting, we are piping. Okay, we're connecting the output of one program, which is hello in this case, to the input of another program, which is WC in this case. And then you press the enter key, and it tells me this is the output out of WC. It's telling me that whatever I input into WC has 1 line, 2 words, and 14 characters. Are we still doing okay so far with the demonstration? Still okay? All right, excellent. And that's what the piping is, in this particular notes here. So you can always refer back to the notes if you want to get a text description of what I just said. Okay, but I think the demonstration is a little bit more interactive, and to some people it's easier to understand. And the next one is the alternative to the C++ Hello World program. And this one makes use of, it keep messing up all the formatting because of the, I shouldn't blame anyone else except for myself, because I was the one who modified the Moodle code to change the standard, but I had a reason to do it. I just forgot to change all of the references here, so I'm gonna do it. So for all the spans, now already. I'm looking for all the spans that does not specify class equals code. I think the rest all have it. Okay, so that's the only one I missed. There we go. All right. So this is the alternative to the alternative C++ program, and the program looks like this. See how nice it's displaying now. And you can see that there are a few differences. Okay, the first line is pound including something that's different. I'll explain what is a header file in time. And then on line 3, we have a using namespace std. It is explained in this notes as well. And then we have the main program. The main program, instead of using printf, is using cout, blah, 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 hello world. This part is still the same. And I do not use \n to specify the end of line. Instead, I use end line here to specify the end of line. And this program is a C++ program. The previous one is just a regular C program. In other words, the previous version using printf can be compiled using just regular C compiler. Okay, this one can only be compiled using C++ compiler because it's making use of object-oriented programming. All right. So the explanation is all in here as well. Okay, on line 1, the header file is specified differently, and I have a hyperlink here to talk about why there's no .h after IOStream. Okay, so there's a long historical reason for that. Okay, it's not technical in any way. It's just convention more than anything else. On line 3, we see a new construct, which is using namespace std. If I do not have this line here, the program will still be okay as long as I qualify cout with std : and nl with std : okay, I'll explain that when I type this program up. \n is no longer \n here. I'm using nl, n line, in order to specify the same thing. So for the most part, it's the same kind of program, but represented differently. And here's an explanation from here to here. Is an explanation of why I'm not using \n. It has to do with different operating systems do not like to talk to each other. Okay, in Linux, as we saw already, we use a single \n or single line feed character 0a in hexadecimal to represent the end of a line. In OS 10, on all the Macs, it uses a single carriage return character to represent the same thing, which is represented as 0D in hexadecimal. In DOS, Windows, and the whole bunch, it uses 2 characters to represent the end of a line, which is a line feed followed by a carriage return. So now that means if you edit a text file and you copy that text file verbatim, byte by byte, from one operating system to the other one, it may not open correctly anymore. It depends on how smart your editor is. Now, some editors like VI is pretty smart. Okay, it can actually see the input file and go like, oh, this is a DOS format, or this is a Mac OS 10 format, and it will understand it and open it correctly. Others, like Notepad, is not so smart. If you create a file in Linux and you put it into Notepad in Windows, it will display as one single line because it doesn't understand a single character of 0A in hexadecimal means end of line. It kept looking for carriage return and line feed together and couldn't find one, and so it puts the entire program on one single line. Okay, so that's basically what this part is about. And by using AND-L, okay, we can make the program more cross-platform compatible, because now it depends on the platform that it's supposed to be run on, and they can use a different standard. The thing about redirection and piping has nothing, absolutely nothing to do with C versus C++. It's just a feature of any program written on a Linux platform. So I can write a program in assembly language and it's still the same thing. It still has input, standard output, and so on. Right. Are there any questions about the C++ version of Hello World, which is this one here? No questions? Now, the approach of doing things is very different between C and C++ as far as files are concerned. We will learn both in this class. Okay, so this class will give you exposure to both the traditional C way of doing things and also the newer way of doing things in C++. All right, if there are no questions about this, we'll go ahead and say, but how do I print a value of a variable? Okay, so I'll give you this program here. So we'll take a look at the program, you tell me what it's supposed to do, and then we'll go ahead and run it. Okay. What do you think? Just reading the code of the program itself, what do you think this program is going to do? Well, first of all, in the loop here, in the first iteration of the loop, what is the value of I? 0, right? Because that's how we read a for loop. The first portion up to the first semicolon is the initialization. So in this case, we are declaring a local variable I, which is only accessible to the for loop, and initializing it to 0 at the same time. That's the initialization part. When the loop exits, what is the value of I?
16.
It's going to be exactly 16 because we stay in the loop as long as I is less than 16. So the first chance you have to get out of the loop is when I does equal to 16. And what do I do in each loop? What do I do in each iteration? At the end of each iteration, I should say. We add 1 to I because that's the post operation. Okay, so knowing this, if I tell you line 7 is going to print the value of I, what is the first value that it's going to print? Is it 0 or is it 1?
0.
It is 0 because plus I is what we call a post operation, which means it occurs after we perform the body of a for loop. So that's why the first value is printed. It's going to be a 0. Okay, so now we can actually focus on line 7, now that we know, generally speaking, what the program is going to do. So we now take a look at line 7 and go like, wow, that is a lot of stuff. And it's kind of cryptic too, okay? And for the most part, I can kind of read this part here, okay? I in decimal is, and then we have a comma, a space, I in hexadecimal is, but what is this %d and the %x doing here? These are called formats, okay? And that's why printf is print formatted, because in the string that you specify in double quotes, if you have anything that starts with a % symbol, it means it is specifying a placeholder of something that has a value that you will specify later. So that means in this case, %d itself, this entire thing, is a placeholder. And so is %x, it is also a placeholder. And both of these are telling printf and say, oh, this is just a placeholder. Expect an integer to be specified later on, okay? So %d is doing the same thing as well as %x, which is also saying, oh, expect an integer to be specified later on, okay? So if they're both expecting just an integer later on, what is the main difference? The main difference has to do with how that integer is going to be printed. In %d, the integer is going to be printed in base 10, which is the usual decimal representation that you and I are used to. And then the other one is in %x, which is printed in hexadecimal. In other words, I'm going to specify two integers, one printed in base 10 and the other one is going to be printed in hexadecimal. But these are placeholders only. How do I know what is the actual value that I'm supposed to print in place of the placeholder? This I goes to the %d, this I here goes to the %x. In other words, the value that is supposed to be printed in place of the placeholder is specified in the same order as the occurrences of the placeholder themselves within the format string. Are we kind of doing it okay here? Okay. Now obviously this expression only has to be an integer, doesn't have to be I. This one, same thing, can be any type of integer. I'm using I and I here just so that we can see, oh, okay, so this in hexadecimal is this in decimal. That's basically what the program is supposed to do. Are there any other questions about this code before we give it a test? Okay, we'll go ahead and type the program in and give it a test run. Any questions? Yep, go ahead.
So the placeholders, can they be put next to the variables? So
No, they have to be specified in the string, in the format string. This thing here, the first argument to any printf is called a format string. And the format string is, what you specify. You can specify stuff that would just be printed verbatim. Anything that is not a % something is not a placeholder, so it would just be printed the way you specify. So in this case, I in decimal is a space, is really just printed the way you specify it. The %d and the %x are the only parts where it has to be replaced by the actual value by an expression that you specify after this format string. Okay. Yep, go ahead.
So if the two i's on the end of that are just placeholders, what goes in there? Like, where does that go?
The first I goes to the first placeholder, the second I goes to the second placeholder.
Okay. But like, what is going, so it's just going to print I? Or like, what is?
It's going to print the value of I. Okay, that's a good question. Let me see if the other question is related. Yep.
So we use the backslash n for the new line. Should
Yes.
we use the other form?
I cannot because this is using the C way of doing things. It's not the C++ way of doing things. So with this one, I can only spell out the exact characters that it has to print out. Okay, but let me address the other question. This part here can be any expression in integer that has an integer type, and this will print out that particular expression. So if you wanted, this can be I times I. It can be just a constant like 3. It can be a huge long expression like this long, but as long as it is of integer type, it will still be okay. Those are all good questions. Any other questions? Okay, if there are no questions, we'll go ahead and run this program. That's pretty easy. Copy, go back to here, cat the program to print integer.c, and paste it. Control D here. I have to get rid of the leading spaces. Okay, print int.c. I'll do the same thing. Line 1 to the end of file. Substitute the first 4 spaces of a line with nothing. Okay. And G++ dash C dash. I don't need anything else. That's good. So print int.c, G++ dash O, print int.o, and then just print it, and that's the output of the program. So it prints, I in decimal is 0, I in hexadecimal is also 0, but it stays the same until we get to the decimal representation of 10, which is represented as A in hexadecimal, 11 is B, and so on. Are there any questions about the output of this program?
So I didn't realize before you put it in that the loop was actually going to print every single time the value changed.
Correct.
So if we were to use the program you used earlier to mod undefined factor, put a really high factor in, it's going to print all of that out until you find a.
If you put a print in that program, yes.
So can we do that?
To do what? To put a print?
Just define a prime factor.
But the objective is really just to return that value, not to print that value. This is printing. Now, when you're printing something, it is going to the console or going to standard output file, but it's not the same thing as returning it in a subroutine. So your job is to specify the code so that local variable factor stores the actual factor, and it will use it to return to whoever is calling the subroutine to begin with.
Is there a way to print our return type? So say we return the prime factor, can we print that out additionally, or do we need both libraries to do that?
You will also need to use stdio if you want to use printf. But remember, printf has nothing to do with returning at all. So you can do one or both, or just one or the other, or none at all. Okay, because those two concepts are different. Returning means I'm going to specify a value that can be used in place of the invocation itself. That's a return statement. A printf is just saying, oh, this is what I want the output to be of this program, but it doesn't specify the return value of a function invocation at all. So those two are completely separate concepts. They can be used in combination, okay, but in your homework assignment, you don't have to use any printf.
The only reason I ask is because instead of going into GDB and testing all the cases, we can just print it out.
Okay.
And then everything that we can print.
That is a good point. Okay, so the point you're making is instead of using GDB, we can now use printf, to debug a program. That's a personal thing. I know there are instructors who tell students in this particular class in cisp360, do not mess around with GDB, just use printf to debug a program. I disagree with that approach. I think using GDB is the proper way of debugging a program. The reason I do that is because in GDB you can stop a program. You can, when the program has stopped, you can now examine the values of all the variables, and then you can single step the program, which means if you know the program is not behaving correctly, then in your mind you have, okay, this is what I think the program should do, but when you single step, at some point the program is going to go do something that you're not expecting, and that's why the program is quote unquote buggy, right? And with single stepping, that's the only way you can tell, unless you put in like a printf for every single line, which will give you an output about this long, and it will be very hard to go through. So I personally believe the use of GDB is the proper way to debug a program, and I think it is appropriate for a class like this to use GDB instead of the printf approach.
Absolutely. I didn't mean to replace your GDB. I know it's precious to you. I was just saying, just so we can get like an initial test case, print it out, and make sure it's right. We can go in and
I would do that in. Let me see. Let me go back to that program. Did I make a folder for that one? Yeah, I made one for 5x2. So this would be a good demonstration too. So in this program, which is now a mess. Okay. Now there are ways to reverse, like big messes like this. They're called beautifiers. So I can look up, beautifier C++, and I'll look for one that is in the Debian distribution. Okay, so we'll go take a look. Code beautifier for Linux. Uncrustify. Program called indent and CB. I think CB is probably the right one, so let's look it up. CB. For C++ programs use BCPP. Okay, let's see if it's already installed. CB. Yep, it's already installed. Oh, no, that's not the same thing. Go ahead and install it. CP. Nope. Did I make a mistake? BCPP, let's try that. There we go. All right, right, so this command is new to me, okay, just like it's new to you. So now the question is, how am I going to use it? It's still being installed and taking this time. Okay, so the key is to use man page, okay, manual page. So I can now look at the program name, which is BCPP, and it says, you know, make C++ beautifier, okay, and that's what we're going to do. And it usually comes with a syntax. The program will run under Microsoft DOS and Unix platforms. Operation BCPP-FI, which is the input file, and then the output is going to the standard output. So normally it doesn't capture it. Okay, so I think I know enough about this one already. So I can now specify the main.cpp as my input, and now it outputs it. And you can see this is the actual output, okay, which is not helpful, right? Okay, this is a test of something that we have learned just today, okay? Given the program is doing something like this, okay, BC++, -fi main.cpp is giving me the beautified version of the program, but it's dumping it to the terminal, dumping it to the console. What should I do at this point if I want to store this program into, let's say, main1.cpp so that I can go back and do some editing? Hmm? Not pipe, it's the other one, which is redirection, the greater than symbol, okay, the greater than symbol. So I will run exactly the same program, but this time I use the redirection symbol to main1.cpp, which is basically just specifying a box to store everything that's coming out of the conveyor belt, okay? And then we look at main1.cpp. Ah, nice, it's almost there, okay? And I said almost because I don't really like to tap that much, okay? In VI, you can set the tap stops to, you know, a particular number of spaces. I personally like 2 or 3, okay? You know, your preference can be different, but I just kind of like the slightly more dense, you know, look of this program. Now, to get back to what you were asking before, okay? Oh, it did not beautify this part. I don't know why. Oh, it's because it doesn't have any open and close curly braces. It only beautifies stuff that has, you know, open and closed curly braces. Okay, so what we'll do is we'll go ahead and use what you said here. So I can say the maximum of 1, 2, 3 is %d as a placeholder and the end of line here. And if the syntax highlighted makes it hard to read, I can turn it off. There we go. All right. So I think this is what you were referring to is, you know, I just want to print out the final output of a particular function call to standard out so I can see it more quickly instead of having to go into GDB to find out what it does. So you can certainly do that with find factor. But you know, GDB is pretty easy to use, and by the time you have a test script, because I recommend people to use the same concept for find factor, so you can test, you know, 2, which is an obvious case, but you have to test 2 because it's also considered a boundary case, because it is the first prime number. I would test 2, I would test 3, and then if it does work for 2 and 3, it's most likely to be okay with the first few prime numbers. Then I would jump to like 13, okay, which is also a prime number, and then go to maybe 91 because it's 7 times 13. So by the time it gets to 91 and then 97, which is not a prime number, which is a prime number, it's probably going to work for all cases. Okay, so you kind of have to figure out your own test cases. But I would do it in the script, just like, you know, with the previous program, just so that you don't have to repeatedly type in the same commands over and over again. But this is one quick way to make it output the actual result. And I'll go ahead and finish this program just to show you what it does. Okay, so I'm going to shortcut this and just, you know, make main1 executable right away. Oops. There we go. Oh, I have a little problem here. Printf is not declared. Okay, when you see something like this, it's because I forgot to do a pound include stdio.h. Okay, when you use printf, you have to include stdio.h. So compile, run, and that's the output of the program. The maximum of 1, 2, and 3 is 3. But I would not put, you know, like a lot of printfs for debugging purposes. You know, I think it really is not a good way to debug a program. All right. Well, it is 10:30. I went a little bit over time, for this class, for the lecture portion. So I'll let you guys have a 10-minute break, and then when we come back, we'll do the lab portion. And I forgot what it was. Oh, the alternative solutions and one tricky way to trip up a program for Find Max 3. So when we come back, we'll do that.